Hi there folks, Root Beer here, continuing our look at the 2005 Grade 9 Pascal paper. We're on question 22. In the diagram, two pairs of identical isosceles triangles are cut off of square ABCD, leaving rectangle PQRS. The total area cut off is 200 meters squared. The length of PR in meters is... So we got some isosceles triangles. Let's get our notepad out and draw a picture of this. So we'll leave question 21 behind. And so we've got our square. And we cut off an isosceles triangle here and an isosceles triangle here. They're pairs of identical ones. Two pairs of identical isosceles triangles. Now, we've got right angles here. So there's no way that these hypotenuses are part of the equal sides. So we're going to have this side equal to this side, and this side equal to this side, and they're identical, so it's the same thing. And then we have two more isosceles triangles, both identical, so we're going to get this equal side, and this equal side, and this equal side, and this equal side. Now, since they're isosceles, so we get these right angles here again, but since they're isosceles, we have the same angle here, and that's going to have to be 45 degrees. So we're going to have 45 degrees all around. Now we're told what? That the area that's cut off, so the area that is the sum of all these, so the big one plus the littler one up in this corner plus the small one down here plus the little one down here. We're told that that was what? 200 meters squared, correct? Yeah, the total area cut off is 200 meters squared. The length of PR. Okay, so PR is diagonal here. So let's add that length in. We'll make him green. We'll have P, Q, R, S here. So we want that length right there. And we're told, the only other piece of information we had was that we've got a total of 200 taken off. So I noticed, just because I was thinking of all these right angles here with the isosceles triangles, I know we got a right angle here. So by Pythagoras, I know PR squared is PS squared plus SR squared. And we've got these other right angle triangles here, so I guess I should add in the A, B, C, and D. So PS squared, well, that's the hypotenuse of this upper left triangle squared. So that's going to be AP squared plus AS squared. And similarly, the SR down in the corner, we can get it's SD squared plus DR squared. But those are the same length, so we get 2AP squared plus 2, DR squared. And so we get 2AP squared 2 times AP squared plus DR squared. But I don't really know. I don't know what AP is. Heck, I don't even know the side length of the square. So even if I knew AP, I wouldn't be able to get DR or anything like that. So what are we to do? Well, we haven't used this information about the sum of the areas. And depending on what sort of things you've seen in your life, you might have seen a nice little proof of the Pythagorean theorem that looks a lot like this sort of setup. So it's just a little proof of the Pythagorean theorem. So a squared plus b squared. What we do is we put the same sort of triangle, but we rotate him. And this sort of setup comes to mind. just because it looks a lot. Now, in this, in the proof of Pythagoras, A and B, they're not the same, so it's not isosceles triangles. But the nice thing about it is, so we get A plus B is the total side length of the square. And then down here we have C, so this guy in here is C squared. Plus, and then what is the sum of these four isosceles triangles? Well, it's 4 times 1/2 AB, right? But another way to see that, because that's just saying it's 4 isosceles triangles, but another thing we can do is sort of shift this guy down, and he forms a full rectangle, A times B. And so this is what has sort of caught my eye. Because if I were to take the setup we have in this question with our isosceles triangles, and I shift the big one down, APS, it's going to form, because we've got the same side length, we're not going to get just a rectangle of sides AB, we're going to get a square. And we do the same thing with the other one as well. Oops. So 200 is not the sum of 4 isosceles triangles, but the sum of 2 squares. Squares of side length AP and DR. So I don't actually need to know what AP and DR are. I just sort of take our smaller one and I slide him on up. And he fits into place. And we get a square because they're isosceles right-angled triangles. So this is AP squared and this is DR squared. So PR squared, which is the thing we want, is twice AP squared plus DR squared. So twice 200. So that's 400. And did we want PR squared or we wanted PR? The length of PR in meters is, well, what's the square root of 400? It's 20. So we get B, 20. Nifty. And we'll flip the page in our notebook in anticipation of the next question, question 23. I'd like to once again remind you should try these questions before watching the video, just so that you can identify your weaknesses and see how you naturally do these questions, not how you do them after seeing a solution. But yeah, that's it for me. Have yourself a wonderful day, and join me for question 23 in the next video.